You're recording. Okay. All right. We'll see how this works. So either will or it will not. All right, so we were talking about horizontal asymptotes. We went through the three rules in which if the two exponents were the same, it was just y equals a over b, basically divide the coefficients. If the top exponent or the numerator's exponent was larger than the denominator's exponent, did not have a horizontal asymptote, which leads us into slant asymptotes that we'll get in today. If the denominator is larger than the denominator, if the denominator is larger than the numerator, then we saw it's just simply y equals 0. So those are the three things you need to know for horizontal asymptotes. So the question states, identify any horizontal asymptotes and then any spots at which it might cross the horizontal asymptote. To do that, again, we're just going to focus on the highest exponents. Oh, I thought you already wrote it down. Wow. Yeah, we did this one yesterday, and now we're on this one. I'll give you a chance to write it down. I don't know. I've taught remedial colleges. I've taught college classes at high school. I've done night school. I've taught remedial colleges, remedial classes at colleges. I think it's all the same. I enjoy it all.
I just mean like you're not like us for
Oh no, no,
like, I feel
yeah.
like like that.
Yeah, you'll have some professors that, because some professors just think that I'm only going to get to know you for 16 weeks and then you're out. We're like teachers, we get to see you all year.
Yeah.
And then I see you for multiple years because then I'm at the same high school. So I can understand like a professor at an actual college, that's all they did. Don't waste my time. Because really and truly, if you think about it, you're only going to see the professor 2 to 3 times a week. So the professor will see you either 32 or 48 times. So they might get to know your name, but then there's by the time they got it memorized, semester's over and they're on to another group of kids. So I can see why they probably won't waste their time on it, but I don't think I would ever be that professor. I haven't been before. All right, so we pay attention to the highest exponents. We got it written down now. Okay, so since the denominator and the numerator's exponents are the same, all I got to do is just divide their coefficients. So that means that my horizontal asymptote will be y equals -4 divided by 1, which is simply just -4. There's a leading imaginary term of 1 there. All right, and then that's it. Then part B then states, well, if the graph of the function has horizontal asymptote, determine the point, if any, where the graph crosses the horizontal asymptote. So what you're going to do is you're going to simply take the original equation, and then you're just going to set it equal to what you got for the horizontal asymptote and just solve. If you get an x value, that means it crosses. If you don't, like I think on the yesterday we saw that 8 equals 0, not possible, so there isn't any. All right, so here we go. So we get -4, and this is part B. So we get -4x squared plus 5x minus 1, all divided by x squared plus 2 equals -4. And to solve rational equations, the best thing to do is just cross multiply and divide. So I put this over 1, and then I'm going to cross multiply here. So -4 times x squared plus 2, I'm actually going to go ahead and distribute the process. So that gives me -4x squared minus 8. And then 1 times anything is just going to be this big guy itself. So it's going to be -4x squared plus 5x minus 1. All right, and then we go about and solve. So what would you want to do first to solve? Not in the first one, it doesn't. Oh, okay, I got you. Okay, that's not, you can do that. It's completely okay. I would probably like to combine my x squares first. So I'm gonna add 4x squared on one side. And I'm gonna add 4x squared to the other side, because what I do to one, I have to do the other. And then what do we see about the x squares? They cancel out. So now you're left with -8 equals 5x minus 1. So in this situation, instead of adding the 8, what would I do instead? I would add the 1 to get x by itself. So I'm going to add 1. So I get -7 equals 5x. Then what would I do? Divide by 5, the number that's next to the x. So I would divide by 5. So we see that x equals -7/5. So we actually do get a value this time. So therefore, on part B, where it says if the graph of the function has a horizontal asymptote, determine the point where it crosses. Well, it's going to cross -7/5, comma, what the horizontal asymptote, which would be -4. There you go. Questions on that? All right, go ahead and take a time to write this out. Questions are the same. It's just a new equation. So for the ones that are listening to this lecture, 3.4 is officially due today on Thursday, October the 26th. And then 3.5 and 3.6 will be pushed to Sunday, October 29th. And 3.7 will be pushed to next Wednesday, November the 1st. All right, ready?
It doesn't have a horizontal.
Perfect. But in this situation, it's not asking us to find it, so we don't have to waste our time. But that makes it life a little bit easier for us. All right, so yes, I pay attention to the highest exponent. I see that the numerator is larger exponent. So therefore, on part A, there is no horizontal asymptote, right? And if there's no horizontal asymptote, there are, oh, geez. Yes, no, the denominator's less. I think that's what I said. So the denominator is less than the numerator, but the numerator is larger than the denominator. No, so if the denominator would have been larger than the numerator, then it's y equals 0. If the numerator is larger than the denominator, then it's none. And because there's no horizontal asymptote, there are no points that cross a horizontal asymptote that does not exist. So that one's super straightforward and easy. Any questions there? Last objective in 3.5, which is identifying slant and nonlinear asymptotes. So I'll give you an opportunity to do this one or write it down. And imagine if this is how large the class was. It'd be like a one-on-one tutorial the entire semester.
You might get that.
I know, I keep scaring my kiddos. Oh yeah, that's exists forever. I still had to do fast when I went back to college to get my master's.
So everybody basically, you actually.
You don't get like any grants or scholarships, but you can get federal loans and aid and stuff like that. Things that you have to pay back. Unless you have like your parents are military or some other
So I
situation.
was like, what does it really do?
It's almost like kind of filing taxes. Like you have to do it if you're going to college. So that when you file your taxes, you actually get a like some relief on taxes because you're in college. So they'll give you some money back. Yeah. Just don't blow it in a sense that you end up going to a college and you end up partying or focusing on your sport and forgetting about your classes. Mhm. Yeah. The only point you get to yourself and you're like, C's get degrees is when you're like, this class is the hardest class I've ever been in. And if I just get a C, I'll be happy. That's when you start saying that. Don't go into it just like, oh, if I just get a C, I'll be good. All right, so there we go. So on this one, for there to be a slant asymptote, there can be no horizontal asymptote. So therefore, that means that the numerator's exponent has to be larger than the denominator's exponent for there to actually be a slant asymptote. After this point, we are going to divide the two. Synthetic division is really nice, but synthetic division only works if it's a linear function that you're dividing by. Since there's a quadratic on the bottom, you'll have to do long division. I don't know where you're at with long division from last year in pre-cal, but let's teach it as if you've never seen it before. So I'm going to take the denominator, put it on the outside of the house. Nonlinear, it just means that you can get a linear slant asymptote, but it could also be nonlinear as well. So we could have just a line, but there could be an imaginary U shape that the graph won't cross. There's weird asymptotes that could happen. And I think on this situation, you're actually going to see a quadratic. When you are setting this up for long division, though, you have to have a place value pretty much for every term. So let me, not +1. I guess I think it'll be all right. So because there's no x cubed, would represent it with a 0. If you put a 1, now you're changing the value. So this would be plus 0x cubed. What? There's a constant. It's a -4. Yeah, but I'm going to put a 0x. But 2x squared plus 0x minus 4. For some reason, I don't have memory of this. Like I know how to do it, but I don't remember if I'm going too far in depth. Hmm. Oh, okay. I see what I did. All right. Anyway, so I keep on going. So what I'm going to do is the way this works, it's a 4-step process. We'll take the first term, divide it by the first term. So I'll come over here and I'll do some side work. So 3x to the 4th divided by x squared is what? Yes. All right, so that value that you just got, you're going to line it up with its like term. So I'm going to write the result right here. So 3x squared. That's step 1. Step 2, you're then going to multiply the results from step 1 to the denominator. The denominator is the term or the polynomial that's outside of the division house. X squared plus 2.
Good.
So this whole thing is the denominator. Yes. So I'm going to take 3x squared and I'm going to multiply it to x squared. And what do I get? Good. So I write that right there, keeping my terms lined up. And then that gives you 6x squared. So I'm going to skip over here. But you want to keep it nice and organized because this is where things can get lost. Step 3. Divide first term by first term. All right, then step 3, we're going to change the signs. So I'm going to come over here. This positive 3x to the fourth will now become a negative. This positive 6x squared will now become a negative 6x squared. And then the last step is combine like terms. So then 3x to the fourth minus 3x to the fourth, what happens? You want it to cancel. If it does not cancel and you're actually left with something, go back and check your work because you've done something wrong. That part, it needs to cancel. I don't have any x cubes. So I'm not going to worry about combining anything there. And then I have 2x squared minus 6x squared. That gives me what? All right. And then I'm going to drop down the remaining part of the equation. So 0x minus 4. And then you repeat steps 1 through 4 until you can't go on any further. So when I do that, again, I'm going to take the first term, which is now negative 4x squared, divide it by the first term, which is still x squared. So I'll come over here and I'll write a 1. So I'll say negative 4x squared divided by x squared gives me what? Just negative 4. Good. The x squares will cancel out. So it'll be just negative 4. Again, I'm going to line that up with my like term over there. Okay. You ready? You're now confused or not confused? Okay. That's the key to this part. Yes, I'm only dividing the new first term by the first term of my denominator. I don't really focus on that until I get to the step 2 where I have to multiply. All right, so that's where we're at now, is step 2. So I'm going to take the result that I just got, and I'm going to multiply it to the denominator. So negative 4 times x squared gives me good minus 8. Again, I'm lining up my like terms to keep myself organized. In this case, you'll see that we didn't need the 0x cubed or the 0x, but sometimes you do. So you got to have those placeholders so that we don't get lost. All right, then step 3 was what? Change the sign. So now it becomes positives. And then what was step 4? Combine like terms. So negative 4x squared plus 4x squared is, they go away, which is what we wanted. And then I have negative 4 plus 8, which is 4. All right. Now, what you would try to do is keep going. However, if I take 4 divided by x squared, does that go into it evenly? No. So this guy right here is called the remainder. And it is not needed in our answer. So the only answer we have is the result that we got up here. So our slant asymptote, usually they'll write it like y equals. So they'll say y equals whatever this result is. So 3x squared minus 4. And that's your answer. Questions? Yes, so that is our non-linear slant asymptote. All right, so we're good there? Uh-huh. All right. So let's write this one down and we'll try this one out. And I'll show you what you can do that's a lot quicker than what we just did in a situation that looks like this. And then we'll move on into 3.6. Now officially conclude 3.5. No. 3.7 isn't either. It's just, I don't think I have time to do 3 sections in a day. That's what I was just about to check. 24. Yep. All right, here we go. So it tells me to identify the asymptote. So I look at it, and this is wanting everything. So when I'm trying to identify all my asymptotes, I look at the horizontal asymptote. Do I have one? No, because the numerator is larger than the denominator. So there is no horizontal asymptotes, which I can't use this. There's no horizontal asymptotes. To find vertical asymptotes, to kind of go back on that, we have to factor the top. And so when I do that, I do have a negative there that makes the life a little bit harder. So what I'm going to do is I'm actually going to go ahead and factor out that negative so that I'm left with a 2x squared plus 3x minus 7 over x plus 3. And again, we do this to see if it's a whole and not a vertical asymptote. So that's why we're doing this part. And now we have just our normal AC method. I guess I'll put the, yeah, so I need to do some side work. So I'm gonna do AC here. So 2 times -7 is -14. My B is 3. So what two numbers multiply -14 but add to 3? It's a positive 3 because we changed the sign. I don't know. I don't think there is. You got 1 and 14, 2 and 7, 4 and 3 is 12, but 2 and 7 is the last one. Yeah. So in this case, it's not factorable any further. So then I can just go into setting the denominator equal to 0. All right. So then my vertical asymptote would be x plus 3 equals 0, which is basically just x equals -3. If you go straight to that answer, I'm good with that. I'm just showing what happened. All right, so we have no horizontal asymptote, which means that we have a slant asymptote. So we'll have to find that here in a second. We did have a vertical asymptote, so let's go identify the slant asymptote. Now, we could do long division here, and it will give you the same answer. But if your denominator is a linear function, meaning the highest exponent is a 1, the other one had a square, so that was a quadratic, I can use synthetic division. So the window number is going to be what x, if you set x plus 3 equal to 0, so that would be what? -3. So -3 becomes the window number. And then I'm going to write all the coefficients of my numerator. So the coefficient of x squared is -2, coefficient of x is -3, and the coefficient of my constant is 7. Perfect. Drop the first number down. And then two-step process. So -3 times -2 is 6. Step 2 is to what? Add, right? So then -3 plus 6 is 3. And then -3 times 3 is -9. 7 plus -9 is -2. And if you recall, this number again is called the remainder. All right. All right, so and then the degree will drop. So then you're left with negative 2x plus 3. And then we just say y equals that. And this is what we call our slant asymptote. Right, and we don't pay attention to the remainder. If the remainder is 0, that doesn't matter. No, it's a slant because it was not a horizontal. If it's not a horizontal, it's going to have a slant. I could care less what the remainder is. If it's 0 or a random number, it does not matter. I only care about the numbers prior to. And there you go. So that's a good review over all of 3.5. Questions? When it talks about slant asymptotes, we don't use the remainder. If I was asking you to simply actually use long division, then yes, you would bring in the remainder as the answer. That is synthetic division. You would just say minus 2 divided by x plus 3. Just like you would do with a regular fraction when you say, all right, I got 3 and I divide it by 4, so it's 3/4 or something like that. We good here? All right. So again, 3.5 homework officially due Sunday. 3.6, which is graphs of rational functions. We're just going to graph some rational functions. So hopefully this answers some of those questions that you had. So I'll give you a chance to write it down. Yeah, we were supposed to start this Monday. But if I can finish this, that'll literally just put me 3 days behind. I don't know. All right, ready? I want to be honest with you, I didn't memorize it. I see it, and then I work out the problem myself without using the teacher stuff and identify my own method. Sometimes it's the same as the teacher, sometimes it's not. If it doesn't make sense, my head just thinks about it constantly until it does. I have a hard time moving on if something doesn't make sense. All right, so here's our first question. We're going to talk about how to graph the functions by using the transformations of y equals 1 over x and the y equals 1 over x squared. So I'll give you a chance to write this down. One of these parent functions, 1 over x, we've already talked about that you should already know. 1 over x squared is a new parent function that you need to know. The branches, instead of it being on flipped sides, it's they're both going up. They're both above the x-axis because if you square any positive or negative number, what's our result? Positive. So they're both going to be above the x-axis. Yes, and we're going to use those parent functions and our rules of transformations that we learned in the last section to help us graph these functions, which will probably help you on your homework questions you had. Me too. All right, ready? All right. So the 1 over x, to remind you what that looks like, it looked like this guy, because this is what we call the reciprocal rational function. All right. So that's what we've seen before. And so that you can kind of understand a little bit more about asymptotes now that we've finished the previous section, it has that's supposed to be dotted, but it's not doing a very good job as a dotted line. Because that would mess my brain up. Okay, so it has a vertical asymptote at y, not y, sorry, x equals 0. Ugh. And then it also has a horizontal asymptote at y equals 0. So remember, this would be the horizontal asymptote. This would be the vertical asymptote. So that's a function that we are already familiar with. And again, this was the y equals 1 over x parent function. So let's talk about the other one. This will be the 1 over x squared, and it looks like this. Like that. It actually has the same asymptotes at y equals 0 and at x equals 0. So again, this is y equals 0, and this is x equals 0. All right. And then again, this is the y equals 1 over x squared. All right. So those are your two parent functions that we're going to use to help us translate this. So the pattern is still the same when we first learned about transformations. The -1 inside the parentheses is going to tell me what? Go right. Very good. So I went right 1. And what is the +2 going to do? Good. This means up 2. So that did not change from our previous unit. So knowing that this is a x squared on the bottom, I'm going to be looking at this equation. And when I say up and left and right and all that other stuff, I'm moving my asymptotes around. So if I say go right 1, I'm going to take my vertical asymptote and I'm going to go right 1. So, and this is what's looking for really on the homework, is I should be able to go to 1 and there should be a vertical asymptote at x equals 1. No, you just pay attention to the inside of the function. And then this is up 2, so I'm going to take that horizontal asymptote and I'm going to go up 2. So it's looking for those asymptotes, and then after that, just put the branches where they go. The branches are going to stay in the same area, just no longer following the x and y axis. So it looks like this. I wrote, yeah. So any questions then on that? So when you talk about the translations, you're literally just moving it left, right, up, and down, just the asymptotes. It's horizontal. You got it. Perfect. Yep. Any other question there? Oh, and just an FYI, if it's just 1 over x, the inside of the parentheses would be underneath the fraction. So if it was like 1 over x minus 1 with none, you treat it as if x minus 1 was in parentheses. And the numbers that are being added or subtracted to the fraction will still be the horizontal. So like yeah. All right, so we're good there? All right, I'll give you an opportunity to write this down and then we'll talk about it. Not many. I think like 2 or 3. Yes, we'll definitely be able to finish the day. We might even start 3.7. I just don't think we'll finish it for sure. Sorry. I think I got lost over here. All right. Sorry. All right. So here we go. So we're going to graph it. Now, this is not the parent function of 1 over x or 1 over x squared. So we're going to use the stuff that we've learned in the previous section to kind of help guide us. So I can't cancel anything. So my vertical asymptote is what? How do I find vertical asymptote? Nope. 1. I set the denominator equal to 0, and I get x equals 1. All right. What do you mean if they're equal? No, you would factor. Remember, vertical asymptote, you would factor completely. This one, there's nothing I can do to factor. And then I set the denominator equal to 0. When I look at horizontal asymptote, that's when I look at the highest exponent. And is it 0? Are the denominators the same? Not my bad. Are the exponents the same? Yes. So then I divide their coefficients. Good. So it'd be 1 over 1. So that would be then y equals 1. So those are your horizontal asymptotes. So therefore, there's no slant asymptote I got to worry about. However, you do need to make sure if there's any points that it crosses the horizontal asymptote at. So I'm going to take my x minus 3 over x minus 1 and set equal to 1 over 1. And I'm going to do cross multiply. So 1 times x minus 3 is x minus 3. 1 times x minus 1 is x minus 1. If I subtract x's on both sides, I see that -3 equals -1, which is not true. So it does not cross a horizontal asymptote. So you do want to check that. I have a vertical asymptote. I don't have any horizontal asymptotes. So when I go to graph this, I start with my horizontal asymptote, or I start with my asymptotes. So that's going to be 1. And then I got 1 at 1. Now, the next key thing is just kind of figure out where your branches are. You can just plug in some random numbers to kind of see where it falls, and then you'll be good on that one. So if I want, I'm just going to plug in 0 because it's on this side of the asymptote. If I plug in 0, I get -3 over -1, which is what? So if I take the test point 0 here, I plug it in, 0 minus 3 over 0 minus 1, the zeros aren't needed. So it's really just -3 divided by -1, which is what? +3. So if I'm at 0, that means I have another random point at 0, 3. All right, somewhere right there. So that tells me my branch is going to be up here. So I can just go ahead and finish this out then. Oh, make sure on yours you don't cross the branch, but there you go, or the asymptote. And then to see on the other side, I can use another test point. So if I was at 1, I'm just going to choose an easy number, 2. 2 minus 3 is -1. 2 minus 1 is 1. So -1 divided by 1 is -1. So that tells me at 2, I got a point at -1. So I have a random point right there. And that tells me my branch is going to be on this side. And there you go. That's all you do. So to figure out where your branches go, just find some test numbers, plug it in, see what side of the asymptote it falls on, and then you can just finish off the rest of the branch. Yes? What? How did I get this one? Oh, I took 2, the number 2, plugged it in. 2 minus 3 gives me -1. And then 2 minus 1 gives me 1. -1 divided by 1 is -1. So that tells me I have a point at 2, comma, -1. And since it told me it was over here, then I know where the rest of my branch is going to be. Yeah, and this one was 0, 3, which told me my branch is going to be above that asymptote. Say that one more time. vertical asymptote would be x equals 1, because you just set the denominator to 0. The horizontal asymptote would be y equals 1, and it was because the exponents were the same. So I was able just to divide their coefficients, and 1 divided by 1 just gave me 1. Oh, no, that's where we just found the point was 0, 3. Right. Any other question there? All right, let's continue practicing graphing. So here we go. I'll give you a chance to write this down. I now see where I'm at in the book. Made these PowerPoints a while back ago, so I got lost.
One over x squared parent function.
We can't do that because it's not a 1 on top. It's a 4. I see what you're talking about. Yes, no. Yeah. No, it will say in the directions to tell you to use 1 over x and 1 over x squared to help translate the graph. If it just says graph the function, that's when we have to go find our vertical, horizontal, our slants, some zeros, test some points to figure out where the branches are, stuff like that. All right. We got it written down. All right. So first, easiest one to me is always vertical asymptotes, and I can't use this. Yes, so we could, yes, so vertical asymptotes, I want to factor, so this is going to be 4, and you can split this up into x plus 4, x minus 4. If you did not realize that was a difference of squares, it doesn't matter because you could have just taken x squared minus 16, set it equal to 0, and then you would have still got the same result. So as you can see, this right here will still give you -4 and 4, but if I went this route, I would have got x squared equals 16. Take the square root. I'm not going to forget my plus or minus. So I see I get plus or minus 4. So in this one, we have 2 vertical asymptotes, and you would have got that if you factored as well. Our horizontal asymptote would be what? Nope. 0. This does not have an exponent on top. So therefore, the square on the bottom is definitely going to be larger than the numerator. So the answer is automatically y equals 0. So remember, if the denominator's exponent is larger than the numerator, it's automatically y equals 0. So therefore, there is no slant asymptotes I got to check. I do got to see, does it cross the horizontal asymptote? So I'll take 4 over x squared minus 16, set it equal to 0. And when I cross multiply, I get 4 equals 0, which can't happen. So it does not cross the horizontal asymptote. So that's good. So I come over here and now I'm ready to graph it fully. So vertical asymptotes, I have it at 1, 2, 3, 4. 1, 2, 3, 4. So again, that tells me I have an asymptote at -4 and at 4. And then I have a horizontal asymptote at y equals 0. And the graph at no point crossed the horizontal asymptote. So I have 3 branches. I got to figure out where they go. All right. Again, easiest thing to do, choose the number on the left side of -4. What do you got?
What is that?
Choose a number on the left side of -4. So -5. -5 squared would be what? 25 minus 16. So I get 4/9. Is 4/9 going to be above or below that y equals 0? Above. So that means that my branch looks like this. Right, so again, all I did was I put -5 in to figure out if it was above or below 0. Okay. Gotcha.
When you put it, like say you had like one, let's say you're drawing one like that. Then you have like 2 points here and there, and it was like you lines to for the third point, and then number two like this.
I don't follow.
You have like that one, like let's say this was your only thing you had to do.
Uh-huh.
Even if you have these 2 points, it would give you this.
Right.
If you add the third one,
So what
still
so what you would have to know is when dealing with rational functions, they make these curvature lines. So even though if I put a point here and a point here, 2 points make a line, this situation I need to know it goes like this. So you need to know that reciprocal functions.
Simply sit there on the other side of these.
If I plug in 5, I get a positive number as well. So I do get it over here. And then the bell did just ring. So to finish this up, plug in 0 because that's the number that's between the two. If I plug in 0, I get a positive divided by negative. So that tells me that it's going to be something like this. Right? Because we know it does not cross the horizontal asymptote. All right. And then so yeah, I'll just work on the homework. And again, we'll push we did not finish 3.6, so I'll push 3.6 and 3.7 to Monday. All right. Now let's hope that all just recorded. Wow.